Welcome to the second lecture for Chapter 2. In this section, we will cover acceleration and motion graphs, both position and velocity graphs. Acceleration is the rate at which velocity changes. As we've already discussed, a rate is a value dependent on a unit of time. In this case, it's the change in velocity over a given time period. Since velocity is a vector quantity, therefore acceleration is also a vector quantity. This gives it both magnitude and direction. In order to calculate acceleration, it is the change in velocity divided by the change in time. Remember, this gives us the average acceleration, not necessarily the instantaneous acceleration. Since the units for velocity are meters per second, and acceleration is velocity divided by time, the units for acceleration are meters per second, or meters per second squared. As we just went over, the units for acceleration are meters per second squared, or meters per second per second. This means that a change in velocity is happening every second. The velocity is changing each second. In the case below, we have a constant acceleration in the positive direction of 9 kilometers per hour per second. This means that for every second, this velocity will change by 9 kilometers per hour. Will change by 9 kilometers per hour. So after the first second, between the first and second picture here, the velocity is now 9 kilometers per hour. After 2 seconds, the velocity again increases another 9 kilometers, so the plane is now moving at a velocity of 18 kilometers per hour. We will never use the term deceleration. We will only refer to objects whether they are speeding up or slowing down. Acceleration itself, as a vector, can have a directional value, positive, negative, up, down, at some angle, in whatever frame of reference. Velocity does the same thing. When an object is speeding up, the velocity and the acceleration will be happening in the same direction. When an object is slowing down, the acceleration and velocity will be happening in opposite directions. When using equations in physics, subscript, or the little notation below the letter, can denote whether the quantity happens originally or after the action. This is often referred to as before or initial, or after or final. For this class, and throughout most of the book, we will use an x0 or x0 as denoting initial position, and an xf for noting final position, or sometimes just a plain x. While this can get confusing, just stop and think about which quantities are really important and where they belong. Here are the equations from the textbook. While I don't expect you to memorize every one of these equations, I do expect you to know how to manipulate them using algebra. These equations from the textbook are not exactly the same as the ones from the formula sheet given by the AP exam, which are on the next page. I would like for you to follow those more. They're, in my mind, a little bit more straightforward and a little bit easier to understand. Here are the formulas from the AP exam. I would prefer that you followed and used these because I think they'll give a greater understanding of the concept. In free fall, the only force acting on an object is the force due to gravity. This is of a force of attraction that pulls an object downward. Normally, there are other forces of resistance, or frictional forces, you may say, that act opposite the motion. In this case, it is the object trying to push the air molecules out of the way as it moves downward. For this first part, when we're just looking at motion, kinematics in general, we will ignore air resistance. We may start adding it in some other problems once we talk a little bit more about forces. Gravity is a fundamental attractive force between two objects with mass. In our reference frame, between us and the Earth, we always look at this as a downward force or a downward acceleration. The symbol for the acceleration due to gravity here on Earth is represented by little g. It is important to note that it is a small lowercase g and not the large G, which we will look at later on when we look at Newton's law of gravitation. This value is 9.81 meters per second squared. You should definitely memorize this if you aren't already familiar with it. An object in free fall, when thrown up in the air with some velocity, will have the same speed. Keep in mind that it's speed and not velocity because it will have a different direction when it returns to the same height that it was initially launched from. This is just a kind of quick, clever hint and useful when solving problems. When graphing motion, time will almost always be our independent variable, and for that reason it will go on the x-axis of our graph. In this graph here, we have position, our displacement also, on the y-axis, and time on the x-axis. From a line on this graph, we can calculate the slope. Remember, slope is rise over run, or change in y over change in x. In this case, it's our change in position over change in time. That's the exact same thing as velocity. So the slope on a position and time graph, or position versus time graph, gives us the velocity. Here is a sample position versus time graph. The three positions highlighted each demonstrate a different type of motion. In the first position, the change in position is a positive 400 meters over the course of 200 seconds. In this case, the velocity, the change in position over change in time from the slope, is equal to 2 meters per second. In the second position, there is a zero velocity because the position does not change. At this point, if knowing that a zero velocity means that the object is not moving. In the third position, over the course of 400 seconds, the position changes by negative 400 meters. In this case, the velocity is a negative 1 meter per second. On a velocity versus time graph, as we see here, we still have the same characteristic for the slope. Slope is rise over run. In this case, the change in velocity over the change in time. This gives us our acceleration. Now, normally, velocity versus time graphs will be drawn with the zero perhaps in the center of the y-axis. This is because velocity can become negative. You can have a positive and a negative velocity to describe the same motion, to describe the motion of some object. I hope that this has been more of a review for you in graphing motion and coming back to your first physics course. If you need some extra time or you have questions, please make sure to write them down in your notebook and bring them to class tomorrow. Thank you very much.